notes is this right here. This is the definition of imaginary numbers. It says an imaginary unit is described as I the variable, is equal to the square root of -1. Up until today, what have we said the square root of -1 was? No real number. Okay, we said the square root of -1, the square root of -16, the square root of -25, the fourth root of -16. We said the even root of any negative number was no real number. And that was true until today. We have a better answer for that. Okay, now if you'll notice, that's not the fourth root or the sixth root or the eighth root. I is equal to the what? Square root of -1. That's what an imaginary number is. It's equal to the square root of a -1. And the only other thing that you have to know is that I squared is equal to just the real number, -1. So I is equal to the square root of -1, and I squared is equal to the real number, -1. All right, let's look at some examples. We're going to have to add and subtract imaginary numbers. It says when adding or subtracting complex or imaginary numbers, combine the real parts of the numbers and then combine the imaginary parts. The real parts are like terms and the imaginary parts are like terms, but we can't combine a real part with an imaginary part. So in example 1, we can just drop the parentheses and combine like terms. So the real parts are 5 and 7. They're going to combine to be 12, and the imaginary parts are -11i and +4i. They're going to combine to be -7i, and that would be the answer to number 1. So when you're adding two complex numbers, you just combine the real parts and you combine the imaginary parts, and you write that in standard form, meaning the real part comes first, the imaginary part comes second. Example 2, you're going to use what you know about subtraction. We can drop the first set of parentheses, but what do we have to do with the second set of parentheses since we are subtracting? We have to distribute by -1 or change the signs. That all means the same thing. So that means now I'm going to have a +11 and a +6i. Once you subtract your second polynomial by multiplying everything by -1, then you can combine your real parts. Your real parts are going to combine to be 6, and your imaginary parts are going to combine to be +7i. All right, that's an example of adding, and that's an example of subtracting. So in adding and subtracting, you're never going to get an I squared. I squareds are going to come from doing an I times an I. So in adding and subtracting, all you're really doing is combining like terms. Okay? Which you really already done. Couldn't you have done that with the X's? Nobody wants to answer me. Y'all are my class that...
It's just too early.
Oh my goodness gracious.
Wait, so you can't get an I squared by multiplying?
Yes, and that's what we're going to do next. You can't get an I squared by multiplying. So in the next set of directions it says find each product, that means the answer when we multiply, and then write your result in standard form. Okay, so what you're going to do first of all is you're just going to treat an I just like it's an X, because it is a variable, okay? It's just a variable. So if we're multiplying in example 3, we're going to do distributive property. -8i times +2i is what? -16i squared. An I times an I, add the exponents, is I squared. -8 times -8i times -7 is +56i. Okay? Yes.
Slightly dumb question.
Go ahead.
But if I squared equals -1, then do you do -16?
Okay? So you just start out by multiplying like we always do. If you have an I squared anywhere in your problem, because in our rules for imaginary numbers, I squared is equal to the number -1. In your next step, anywhere you see an I squared, you have to replace that with a -1. And then you simplify it out as far as it will go. So now my real part is -16 times -1, which is +16. And then my imaginary part is plus 56i. So a lot of people, once they just get over the fact that I is an imaginary number and you treat it like an x until it turns into an I squared, and then you just substitute a -1 in its place, this section is not that bad. Okay? We're still multiplying. Oh, these binomials look like something that are special. They're conjugates. Why are they conjugates? They're the same except for the sign. So do I have to multiply 4 times if I have conjugates? No, because the 2 middle terms will always cancel. So you can just do 2 times 2, which is 4, positive 7i times negative 7i, which is negative 49i squared. Then we said anytime we have an I squared, we're going to substitute in -1. So that gives us 4 minus 49 times -1. That gives us 4. I like to think of that subtracting 49 as a -49. That's okay to do. So that's a -49 times a -1. That's a positive 49. Final answer is 53. So this number is complex, but it just doesn't have an imaginary part. Okay, it's just 53. So that one works out. The I squared turns into a -1. You don't have any i's in your answer. That could happen. All right, example 5. Multiplying 2 binomials together. Are they special? No, they are not special. If your binomials are not special, you have to multiply all the way out. That means you have to multiply 4 times. 8 times -3 is -24. 8 times positive 9i is positive 72i. -4i times -3 is positive 12i. And a -4i times a positive 9i is a negative 36i squared. You're going to combine like terms. You're also going to substitute a -1 in for your I squared. You can do that all in one step. I'm going to do 2 steps here. 72i and 12i combine to be 84i. And then I have a minus 36i squared, but I'm going to substitute in a -1 there. So then I have -24 plus 84i plus or minus 36 plus 36. Combine the -24 and the plus 36 and you get how much? 12. It's going to come first because we're going to write our answer in standard form. So the real part comes first, the imaginary part comes second. Questions about 5?
Why was it -1 when you changed the I squared?
Just the definition of I squared in the set of imaginary numbers is -1.
Oh, so it's going to be -1.
Always going to be -1.
Okay.
Okay, example 6, we have a shortcut for 5 minus 2i squared. What's that shortcut called? Square double square. So we're going to take the 5 and we're going to square it. We're going to multiply the 2 terms either in our head together or over to the side if you need to. What's 5 times -2i? -10i, and we're going to double that. Okay, we're combining like terms here. So if you have a -10i and a -10i, that's a -20i. Don't have an I squared when you multiply and double. You're just combining like terms. And you're going to square the last term. -2i times -2i is positive 4i squared. Is that our answer? Nope, because all I squareds are going to turn into -1s. So you'll get 4 times -1. That's going to give you 25 minus 20i plus or minus 4. Minus 4, combine like terms. Final answer is 21 minus 20i.
Why would it not put
Plus what?
20i?
Plus 20i. Because if you're combining like terms, her question was, why would it not be plus 20i? So if you multiplied out the long way, you would have a minus 10i and a minus 10i, and those are both negative. A -10 and a -10, you're combining here. So if the signs are the same, you add and you keep the sign.
So you wouldn't, like, you wouldn't take negative 10i and multiply it by 2.
You could. That still gives you negative 20i. You can actually double it by putting it twice, or you can double it by multiplying by 2. You still get negative 20i. Negative 10i times 2 is negative 20i. Negative 10i minus 10i is negative 20i. Okay, the next section says we need to know how to divide and express your answer in standard form. So we practice how to add, practice how to subtract. Now we're going to practice how to divide. Alright, so we're going to use something that we've already talked about. So up here on the side, I'm going to remind you what I stands for. I stands for the square root of negative 1. I stands for the square root of negative 1, and I squared is equal to just a negative 1. That's what real numbers are founded on. Those are the only rules we really have. Okay? So in example 7, if we're dividing by 4 plus I, we can't leave the I in the denominator because it's really the square root of negative 1. And remember, we have a rule that we can't leave radicals in the denominator. So in number 7, it's telling us to divide because we can't have 4 plus I. We could have the 4 in the bottom, but we just can't have the I. So what we're going to have to do here is we're going to have to get rid of the I. That's the same as rationalizing the denominator. Okay? So is your I part of one term or two terms? It's part of two terms. So we're going to use something that we learned in chapter P, maybe. And if the bottom has a radical in it, and that radical is part of two terms, we're going to multiply by that C word. Conjugate. And what's the conjugate for 4 plus I? 4 minus I. Whatever we multiply times the bottom, we also have to multiply times the top. So I have to multiply the top by 4 minus I, and I have to multiply the bottom by 4 minus I. That's the only way you're going to get all of the i's out of the denominator. You can't have an I in the denominator because it's a square root. All right, we're going to do top times the top. Top times the top is not a binomial times a binomial. It's just your little 3 times your binomial. So we're going to do what property here? We're going to just distribute. So 3 times 4 is 12. 3 times negative I is negative 3i. When we multiply the two denominators together, that's a binomial times a binomial. We usually have to multiply 4 times when we have a binomial times a binomial, but are these binomials special? Yes, they're special, meaning the two middle terms will always cancel out if I multiply 4 times. So I don't have to multiply 4 times, I just have to multiply the first two terms. That gives me 16, and what's a positive I times a negative I? A negative I squared. So when you multiply conjugates together that have an I in them, then you're going to end up with an I squared, which is then going to turn into a negative 1, and then the I in the bottom of the original problem will go away. So the top is simplified. 12 minus 3i can't be simplified any further. In the bottom, we need to say 16 minus what? 16 minus negative 1, because anytime we have an I squared, we can replace that with a negative 1. Final answer is going to be 12 minus 3i over 17. Okay? That is an acceptable answer if your book writes it like this. 12 over 17 minus 3/17 I. That's still the same thing. Either one of those will be okay. I prefer the first way because later on I know they use that form. Okay? They might break it up into two fractions. Alright, example 8. What are we going to multiply by? 4 minus 3i. Alright, y'all got the hang of this. Y'all could teach this lesson, right? Alright, we're going to multiply the top and the bottom by 4, what? Minus 3i. Top and the bottom by 4 minus 3i. So the top, I have a binomial times a binomial. Are those special? They're not special. They're not conjugates. Okay? So you have to multiply 4 times in your numerators. Those binomials are not conjugates. You don't have a shortcut. So 3 times 4 is 12. 3 times negative 3i is negative 9i. Negative 4i times 4 is negative 16i. Negative 4i times negative 3i is positive 12i squared. You may need me to go over how I got those 4 terms. When you multiply the two denominators together, they're special. They're conjugates. You made that happen, so you can do the shortcut there. You can do 4 times 4, which is 16, and positive 3i times negative 3i, which is negative 9i squared. And you're going to go up to the top, and you're going to simplify anything that will simplify. What will simplify? All right, I have some like terms. They're going to combine to be negative 25i. My I squared is going to turn into a negative 1. Some people will skip that step and they'll say 12 times negative 1 is negative 12. And you'll just write minus 12 there. So as you start to understand what you're doing, as long as you can get the answers right, if you want to start to skip some steps, you can. In the bottom, what are we going to do? We're going to do negative 9 times negative 1. All right, what happens in the top? The 12s are going to cancel because you're going to have a positive 12 on the left, and when you do 12 times negative 1, you're going to have a negative 12 on the right. So the 12s are going to cancel. So in the top, we're just going to get negative 25i. In the bottom, we're going to get 16 plus or minus 9. Plus 9. So that's going to give us negative 25i over 25. And is that our final answer, or will it simplify? It'll simplify. The 25s will cancel, and your final answer is just going to be negative I. That's probably the hardest part of this section, is doing something like example 8. All right. Moving right along. The next set of directions say perform the indicated operation and write your answer in standard form. So this part is not long, okay? It doesn't have a lot of algebra, but you have to remember to begin with, you have a negative underneath each square root. Does everybody see that? If you have a negative underneath each square root, your very first step needs to be to establish that these are not real numbers. You have a problem that they're asking you to do that's not a real number. So this is the first time you've had a negative under the square root. Out of all the first 8 examples, you haven't had any negatives under your square roots. So in your first step here, you need to bring out the negative as an imaginary number. Okay, you'll get the hang of this. I'm going to show you this part, and over to the side I'm going to kind of show you. And you don't have to write this down. I think you'll understand. Do y'all understand that the square root of a negative 81 could be rewritten as negative 1 times positive 81? Okay, so negative 81 can be thought of as negative 1 times 81. And the square root of negative 1 is what? I. And that's how I'm getting I square root of 81. That's why, okay, I don't want you to ever take the time to do negative 1 times 81. You just need to know that anytime there's a negative underneath the square root, it needs to come out as an I. That's how you start the problem. You can't work this problem with a negative 81 and the negative 144 under. You can, but you'll get it wrong. You can't work it with the negatives underneath. So your first step is to bring the I's out, and then ask yourself what you've been doing for the last 2 weeks. Is 81 a perfect square? It is. What's the square root of 81? 9. What's 9 times I? 9i. Go to the next one. Is 144 a perfect square? Yep. What's the square root of 144? What's 12 times I? 12i. Uh-huh. We are multiplying. We are subtracting. Okay, we are subtracting. My bad. Still do this in the first step. Sorry, thought it looked like a dot from here. Alright, we still got to do that in our first step. Now our problem says 9i minus 12i. Once you turn your numbers into imaginary numbers, then you can add them, you can subtract them, you can multiply them, and you can divide them. So what's 9i minus 12i? Negative 3i. Thank you, Sydney. Okay. You have to take those negatives underneath your square roots, pull them out as i's, and then just simplify the problem using some skills that you've already done. All right, number 10, what would we do first? Hi. Bring out the i's. So we have 5i square root of 8 plus 3i square root of 18. Okay, now you're just going to keep working it the way you know how to work it. What's the next question you're going to ask yourself?
What goes into 8 perfect square?
Alright, is 8 a perfect square? If it's not, what goes into 8 that is a perfect square? 4. So you're going to break 8 down into 4 times 2. So you're going to have 5i times the square root of 4 times 2. Then what are you going to do with the 18? 9 times 2. Then what are you going to do with 5i squared of 4 times 2? Take the square root of 4, which is 2. What are you going to do with the 2 when it comes out? 2 times 5i is 10i. Square root of 2. Then you're going to take the square root of 9, which is 3. 3 comes out. 3 times 3i is 9i. And then you have square root of 2. And then you're going to ask yourself, can I add these two terms? Are they like terms? Yeah. They're both square roots of 2's. So I can add them up. And I just combine the numbers out in front. So a 10i and a 9i, those are just like terms. I'm not multiplying I times I here, so I won't get an I squared. 10i and 9i combine to be 19i, and that's the answer there. All right, in example 11, do you have any negatives underneath square roots? Yes. Yeah. Let's see if we can do this in one step. Let's see if not one total step, but this first part. Whew, scared Mary Frances. All right. Let's see if I lost anybody right there.
Yeah.
Ethan's got it.
Because it's negative 1 is the square root, so you just get positive, or you get negative 3i.
All right, the square root of a negative 9 is 3i. Because the negative comes out as an I, and the square root of 9 is 3. So you're going to start to realize the square root of negative 9 is 3i. The square root of negative 25 is? Square root of negative 25 is 5i. The square root of negative 100 is 10i. Y'all getting that? You can do the extra step there, but y'all will start to figure out if you have a negative perfect square underneath your square root, you'll just take the square root of that number and there'll just be an I beside it every single time. All right? Now this is a binomial square. Do we have any shortcuts for binomial squares? Yes. Sure we do. What's it called? Square double square. So we're going to square negative 5 and get 25. We're going to multiply. Tell me first what you get when you multiply those two terms. Positive 15i, and you're going to double that. So what's a 15i plus a 15i? It's a 30i. And then you're going to square negative 3i. So what's negative 3i times negative 3i? Positive 9i squared.
Could you skip that step and just do negative 9?
That's what I'm hoping that y'all will start to realize. That plus 9i squared will turn into a negative 9. Some of y'all won't be able to skip a step, so I'm going to just show all the steps. Absolutely. Okay, if you can start skipping steps and you're not breaking any rules, then you just start skipping steps. Alright, so that 9i squared is really going to turn into a negative 9. And then once you combine like terms, 25 minus 9 is 16. And then you just have the plus 30i. Yeah, once you get the hang of it, and you know what you're doing, you can start skipping steps. Just be careful. Make sure you know what you're doing. All right, 3 more. Example 12. I need to bring out the negative underneath the square root of negative 12. So let's bring out the I there. Can y'all simplify the square root of negative 4 all in one step? 2i. And minus square root of 2 is not going to change. Does that make sense? So the square root of negative 12, 12 is not a perfect square there. So I'm just going to take out the I and leave the 12 there for right now. Square root of negative 4 is 2i, and then minus the square root of 2. Can't do anything with square root of 2. So are we adding here, subtracting here, or multiplying here? We are multiplying, okay? So what do we get when we multiply the first 2 terms together? 2i squared, square root of 12. Good. What do we get when we multiply the last 2 terms together? Good. Negative I square root of 24. So everybody get that step. Is that our answer?
Would you do 2i squared?
Yes, I said you are right. I think I said I squared and wrote a I. Thank you, thank you, thank you. 2i squared, square root of 12, minus I squared 24. All right, is that the final answer? Or do you see some things that will simplify? Yeah, 2i squared is going to turn into a negative 2. So you can go ahead and write a negative 2. Then what else will simplify? Square root of 12 breaks down into 4 times 3. Square root of 24 breaks down into 4 times 6. Almost finished. Final answer is dun, 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 negative 4 square root of 3. Somebody says minus 2i square root of 6. Good. Questions about 12? Any questions about 12? All right, last 2 examples. Y'all look like zombies. We can do this. All right, example 13 is a binomial squared minus another binomial squared. And you already have i's in your problem, so you don't have to worry about a square root of a negative number. So according to Please Excuse My Dear Aunt Sally, what operation do we have to do first? We have to do the exponents first. So how do I square 4 minus I? Square, double square. Can you give me that trinomial?
16 minus 8i plus 5 squared.
Okay. I do want to put that in parentheses because my next sign is subtraction. And then you're going to square, double square the 1 plus 2i, and you're going to get
1 plus 4i.
how about 4i squared? Square, multiply, and double, square. All right, what's the next thing that Please Excuse My Dear Aunt Sally says? Really? Really? What's the first thing Aunt Sally says? Please. Parentheses. Don't I have some stuff to do inside this parentheses? Yeah, that I squared is going to turn into a negative 1. So I have 16 minus 8i minus 1 in the first set of parentheses. And over here I have 1 plus 4i minus 4. Still have some things going on in my parentheses. So the next step would be 15 minus 8i in parentheses minus negative 3 plus 4i. So finally I've got the please part taken care of. I've done the parentheses.
Did you do your document, Cameron? Do you need me to do it?
I got it hooked up to my desktop.
Okay.
I do have a question about my MacBook.
Well, they're on that one for the version we're running on the Macs. They're wanting you to do the app, and I did Miss Mac Bay a while ago, and it was it comes up, sees the camera, but it's not showing an image.